Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay, so guys, this is the 11th part of the series of CSIR NET Physics June uh, November 2020 paper solution. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so let's get started with the first question. Okay, the first question is, these are very good questions guys, and I'm going to start. So first question of the day, first question is, a parallel plate capacitor, a parallel a parallel plate a parallel plate capacitor parallel plate capacitor with with length L, with length L smaller, breadth B, breadth B, and and plate separation D, and plate separation D is held vertically on the surface of on the surface of a dielectric liquid, a dielectric the surface of a dielectric liquid of dielectric constant of dielectric dielectric constant K and density rho. Okay, as shown in the figure, shown in the figure. Okay, the figure is given guys, I'm going to draw. These are straight lines guys. Okay, okay, so this is dielectric liquid. Okay, these are straight lines. Okay, this height is L, and this height is H. This is the liquid filled up. Okay, and this separation is D. Okay, so as shown in the figure, the plates of the capacitor, the plates of the capacitor plates of the capacitor are kept at a constant voltage difference, a constant voltage difference, constant voltage difference, constant voltage difference V, ignoring effects of surface tension, ignoring effect of effects of surface tension, something missing, let me just check, as shown in the figure, and after that there is breadth are large enough, okay, the length and breadth are large enough for edge effects to be neglected, okay, for edge effect edge effects to be neglected, edge effect to be neglected. Okay, and the plates of the capacitor are kept at a constant voltage difference V, ignoring the effects of surface tension. Okay, the height the height the height the height h the height h up to which the liquid level the liquid level rises inside the capacitor, rises inside the capacitor inside the capacitor is, options are option number A, V square epsilon 0 k minus 1 upon rho g bd. Option B is V square epsilon 0 k minus 1 upon 2 rho GB square, 2 rho GB square. Option C is V square epsilon 0 k minus 1 upon 2 rho GB square. Option D is V square epsilon 0 k minus 1 upon rho GD square. Okay, so this is the question, guys. Okay, I'll read it for you. A parallel plate capacitor, okay, so a parallel plate capacitor of length L. So there's a parallel plate capacitor with length L and breadth B. Okay, and plate separation D. Okay, so there is a parallel plate capacitor which is made of rectangular plates whose length is L, breadth is B, and separation between these two plates is D. Okay, is held vertically, so that is held vertically. This is shown in the figure, this one, right? These are the parallel plate capacitor. Okay, the two rectangle plates which are at separation D. Okay, and they are held vertically on the surface of dielectric liquid. This is the surface of dielectric liquid. Okay, liquid of dielectric constant K, whose dielectric constant is given, that is K, and density, the density of liquid is rho, as shown in the figure. It is shown, right? The length and breadth are large enough for edges effects to be neglected. Okay, so length and breadth are very large effect, that edge effects. Okay, so we have neglected the edge effects because the length and breadth are large enough. Okay, next, the plates of the capacitor are kept at a constant voltage difference V. Okay, so these plates are kept at a constant voltage V. Okay, voltage is V, that is constant. Okay, ignoring the effects of surface tension, so you need to ignore the effect of surface tension, the height up to which the liquid level rises inside the capacitor. Okay, so we need to find out this height. So the height up to which this liquid level is raised. Okay, so this height from here. Okay, the height up to which this liquid level is raised. Okay, so liquid level is raised to this height. This height we need to find out. Okay, okay, the height up to which the liquid level rises inside the capacitor is. Okay, that height we need to find out. Very good question, and it's a formula based question, guys. How to solve it? You need to just note down the formula. Okay, and you can easily solve it. Okay, okay, so I'll solve now. So what we are going to find, first we'll find that force. Okay, upward force on the dielectric. Okay, upward force, upward force, upward force, upward force on the dielectric. Upward force on the dielectric. Okay, upward force on the dielectric we need to find out. So obviously, guys, you can see, because there is a liquid level, right, and because of this arrangement, right, because of the Coulombic force, right, this level of the liquid is rises up to this, right. It means there is a force, upward force, right, because of these parallel plate capacitor, right, that because of that this level is rises up to height as, right, level of liquid. So that force is, there's a formula for that, guys. Okay, the upward force on the dielectric F, this is going to be, you need to note down, guys. Okay, I'm going to write in that, that is F equal to uh, epsilon 0 V epsilon 0 B epsilon 0 B V square K minus 1 upon 2D square, guys. Very important formula you need to note down. Okay, where epsilon 0 is permittivity, right, B is the, this one, the width, breadth of the rectangular plate. Okay, and D is the separation between these plates. Okay, in capacitor, D is the separation, and V is the voltage. Okay, voltage at these two plates of the capacitor. Okay, and that K is the direct dielectric constant. If this is the case, right, then the upward force is going to be equal to this, F equal to epsilon 0 B V square K minus 1 upon 2D square, guys. Okay, that you need to note down. Okay, proceed further now. Just give me 1 second, guys. There is some technical issue. Let me just sort it out. Okay, it is sorted. So now I'll proceed. Okay, so this is the force, guys, and which you need to note down. If you will get this arrangement, guys, this arrangement, right, this type of arrangement, right, parallel plate capacitor, and there's a dielectric, and this dielectric goes up, right, so there's an upward force, and that force is equal to this epsilon 0 b v square k minus 1 upon 2d square, where b is the breadth of the plate, rectangular plate. Okay, well, so now because this is a liquid, guys, and it is rising up to height s, right, and what is the force for that? That means F is going to be equal to, right, if because since liquid rises up to height h, since liquid rises up to height up to height h, right, up to height h, then this force is going to be equal to v rho g, guys. Okay, because this we know, this is the upward force, right, and this is going to be this upward force is going to be equal to this one, guys, this v rho g. Okay, v is the volume of this cuboid. Now v is volume, right, so this is the height, and this rectangle has a the rectangle plate has a breadth d, right, sorry, b, so h in this is length into width, b into that thickness, that is d, right. So we know that volume for this part of cuboid, this is cuboid, right, this volume is height, length into width into length into breadth into thickness, right. So this is going to be, so this force is going to be equal to, because this force is going to be equal to this one, volume is this one, h b hbd rho g. Okay, hbd is volume, guys, volume because hbd is volume, right, volume of this cuboid, right, this is the length h, right, this is the thickness d, and the width of plate is, that is breadth of the plate is b, so height into that, this is length into breadth into thickness, right, so this is, so rho equal to h v rho g, that is the force, because because the liquid is rising up to height h, right, and then force is equal to, this force will be equal to v rho g. V is the volume, it's a volume, not the voltage, guys. Okay, so v rho g value is this hbd rho g. Okay, now value of f is this, so this will be equal to this, right, so this is epsilon 0 b v square, just a formula based question, guys, you need to know this formula, you can easily solve it, d square equal to h b d rho g, b will get cancelled, guys. Okay, so from here value of h is going to be, this one, epsilon 0 v square k minus 1, epsilon 0 v square k minus 1 okay, upon this one, epsilon 0 v square k minus 1, and these will go in denominator, right? So this is 2d square, my apology guys, this is just a d, 2d, okay, this is d. So this will go here, so this is going to be 2d square rho g, right, upon 2d square rho g, okay. So this is the answer, okay. So value of height, this value of h is this, guys, epsilon 0 v square k minus 1 2d square rho g. Which option is matching, guys? Let me check. This one is matching, right? Epsilon 0 v square k minus 1 upon 2 rho g v square. This is d square, guys. We have made mistake. This is d square, okay. So this option is matching, guys. So option B is the, let me just check. No, this one, option C is the correct. This is B is the one, right? My apology. So this option C is matching, guys, because this is v square epsilon 0 k minus 1, v square epsilon 0 k minus 1 upon 2d square rho g, 2d square rho g, okay, 2d square rho g, okay. So this option C is matching. Very simple, guys. We just need to know this concept, okay. If this is the case, because here what happen is, this parallel plate capacitor is placed vertically and there is a liquid inside, there is a liquid beneath that uh, parallel plate capacitor, right? And because of that, because of this parallel plate capacitor and Coulombic force, this dielectric, this dielectric liquid rises up to this height, h height, right? And for that we have a formula, and this happens because of the upward force, right? And that upward force is equal to this, guys, which you need to note down, okay. That upward force is equal to epsilon 0 b v square k minus 1 upon 2d. Here you need to note down b is the breadth of the rectangular plate of capacitor, okay. Next is, we know that because the liquid is rising up to this height, and that force we know, if liquid rises up to height h, that force is equal to v rho g, that we know. And v is the volume, right? That is hbd, right? Height into width into breadth, right? hbd into rho g, we have put the value, and then we have equate this f equal to this, and from there we have found the value of h. And this is 5 marks question, guys. Part C questions we are solving, okay. Very simple. If you know the formula, you can easily solve it in 2 minutes, this question, guys, okay. So this question is done. Next question I'm going to solve, okay. Next question, question number 2. Question number 2. Question number 2 is, I'm going to write this. Question 2 is, using the following values, using the following values, using the following values of x and fx, using the following values of x and fx, okay. So x is given, guys, 0, 0.5, 1.0 and 1.5, okay. And fx is given, that is 1, a 0 minus 5 by 4, okay. The integral the integral I which is integration 0 to 1.5 fx dx evaluated by trapezoidal rule is 5/16. The value of A is option A 3/4, option B 3/2, option C 7/4, and option D 19/24. Okay, so this is the question, guys. The question is, using the following values, x and fx values given, the integral value I 0 to 1.5 fx evaluated by trapezoidal rule is this. Okay, we have evaluated this integration by trapezoidal rule, and that value is this. We need to find value of it. Okay, very simple question. I have already explained trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule, okay, in my mathematical physics lecture, so you can watch that. Okay, so I'm going to solve that. So we have been given x and fx value, right? X is given, this is 0, 0.5, 1.0, and 1.5. Okay, and fx value is given 1 a 0 minus 5/4. Okay, this is the value. This value is, we know, that is x0, this is x1, this is x2, and this is x3, and this is y0, y1, y2, y3. You can check my trapezoid, that mathematical physics lecture, guys. There you will get a detailed analysis of trapezoidal rule, Simpson 1/3 rule. Okay, so now we know the I by trapezoidal rule, we know that is h/2 into initial minus final, means y0 plus y3 into 2 into remaining, that is 2 into y1 plus y2. This is by trapezoidal rule. Trapezoidal rule, right? So I is going to be, and h we can easily find out. H is, value of h is x1 minus x0, right? So that is that interval, right? So that is 0.5 minus 0, that is 0.5, right? Okay, so now we can solve it. So h/2 is 0.5/2 into y0 value is 1 plus y3 value is minus 5/4 plus 2 into y1. y1 is a plus y2 is 0, right? So value of I is going to be 1/4. So if we divide 5.5, if you divide 2 by 0.5, that value is going to be 4, right? So, and then this is going to be 1 minus 5/4, 1 minus 5/4 plus 2 plus 2 plus 2, right? Plus 2a. And since according to question I is given by trapezoidal rule, that is 5/16. Okay, I is given 5/16, right? So this implies 1/4 into 1 minus 5/4 plus 2a is equal to 5/16. 4 will cancel this 16 by 4, so this is going to be 1 minus 5 by 4 plus 2a, this is going to be 5 by 4. From here, value of 2a is going to be 5 by 4 plus 5 by 4 minus 1, right? So this implies value of a is going to be, this is 5 by 4 means is 10 by 4, right? I'll solve this further. So this is 10 by 4 minus 1, so this is going to be 6 by 4, right? So this implies value of a is going to be this here, simple, 2 will cancel this 3 times, right? So that implies, I'm writing here, okay, implies value of a is 3 by 4. Okay, so this is the answer, guys. 3 by 4, and this is the answer. So which option is matching, guys? Let me check. Option A is matching, guys. So option A is the correct option, 3 by 4. Option A. Okay, next question, guys. Okay, next question is also a good question. It's a green function question. I have explained green function in my mathematical physics lecture. You can check that. Okay, question is question number 3. The Green's function the Green's function the Green's function the Green's function for the differential equation Green's function for the differential equation, that is dx upon d square x upon dt square d2x upon dt square plus f plus x equal to ft. Okay, the Green's function for the differential equation is satisfying boundary conditions given, satisfying the initial condition, initial conditions x0 equal to d upon dt x0 okay, equal to 0 is and 0 is given that Green function, that is g, which is function of t and tau, okay, equal to 0 for when t is between 0 to tau. Okay, and value is sine t minus r, t minus tau for t greater equal to tau. Okay, so this is the Green function given, guys. Okay, for this differential equation, the solution of the differential equation. Okay, you need to find out the solution of the differential equation, solution of the differential equation when source ft equal to theta t, okay, the heavy step function, okay, that is heavy step function, the heavy side, okay, heavy side step function Heaviside step function is. Okay, options are A equal to sin t and B equal to 1 minus sin t, okay, and C equal to 1 minus cos t, 1 minus cos t, and D equal to cos square t minus 1. Okay, so this is the question. Okay, I'll read it for you. the green function of the differential equation satisfying the initial condition x0 equal to dx0 by t equal to 0. Okay, and the green function for this differential equation given, that is gt tau equal to g, which is function of t tau equal to 0 for when t is between 0 to tau, and sin t minus tau for t greater equal to tau. Okay, the solution of differential equation you need to find out when source ft equal to theta t. Okay, the theta t is heaviside function is. Okay, and options are this. Okay, so I'm going to solve it for you. Okay guys, this is very simple. We have been given green function, right? Green function is given this, and this is the condition given, so we can directly find out, guys. Okay, I'm going to find this. So this is going to be this one. So solution we need to find, right? There is a formula, guys, you need to note down. The formula is xt is going to be integration 0 to infinity, integration 0 to infinity green function g, this function of t and tau d tau. Okay, this is the important formula you need to note down. Okay, okay, well. So this is the green function, right? So now we'll find the value. So the value of x is going to be xt, that's solution, right? We are finding solution. So solution xt is going to be, so we'll put the value of gt, right? So this is going to be green function, that is integration, because here 0 to t, limit is going to be 0 to t. Okay, sine d tau. Okay, this is d tau. We are going to integrate with d tau. D tau means this one, guys. Okay, not dt, d tau. Okay, for this one. Okay, this is important, you need to understand. So d tau. So sine, this is going to be sine t minus tau, because this value is 0. Okay, this value is 0. Okay, t minus tau, and tau is greater than that, tau is greater than t. Okay, so then this here the limit is going to be, because limit is going to be 0 to t, right? So 0 to t sin t tau d tau d tau. Okay, now we'll solve it. Okay, so here the function is, so we are integrating with respect to this tau, not t, guys. This you need to understand. So now we'll just integrate it. Very simple. So the integration of sin t minus tau is cos minus cos t minus tau. Okay, and then limit 0 to t, 0 to t, right? Sin is cos is plus. Okay, so this is the one. Sine, integration of sine is cos. Okay, so this is going to be 0 to t. Now we'll put the value. So we are different integrating with respect to tau, guys. Okay, tau is the variable we are taking here, right? So instead of tau, we'll write t. So we'll put the limit. This is going to be cos t minus t. In place of tau, we'll write t. Okay, minus cos. This is 0. So this is going to be t minus 0, because we'll put this, right? So this value is going to be, if you solve it, cos 0, t minus t means cos 0 is 1 minus cos t minus 0, right? This is t minus 0, cos t, this is cos t. Okay, so this is the one. Okay, so guys, this is the answer. This is 1 minus cos t. Okay, so the important thing is you need to find out the solution of that. Solution is going to be xt is equal to 0 to t, that limit sine t minus tau d tau. Okay, so here the variable is tau. Okay, and the limit is 0 to tau. So we have just integrated it, and the value is 1 minus cos t. Okay, so which option is matching, guys? Let me check. Option C. Option C is matching, guys. Option C. Option C is the correct option. Option C. Okay, that is 1 minus cos t. Okay, next question. Just give me 1 second. Okay, so this is the question number 3. Okay, now question number 4 we'll solve. Okay, next question is, next question, that is question number 4. Question number 4 is it's a good question, guys, and this question is from condensed matter physics. Okay, so question is, a tight binding model, a tight binding, a tight binding model, a tight binding model, a tight binding model, a tight binding model of electrons, tight binding model of electrons. Okay, tight binding model of electrons in one dimension, in one dimension, in one dimension, in one dimension, has in one dimension, has in one dimension, has has the dispersion relation, has the dispersion relation, dispersion, has the dispersion relation epsilon k, epsilon which is function of k equal to minus 2t, 1 minus cos k, 1 minus cos k, where t is greater than 0. Okay, a is the lattice constant, a is the lattice constant, a is the lattice constant, and k is between minus pi by a2 plus pi by a. Okay, pi by a. Which of the following figures, which of the which of the which of the following figure, which of the following which of the following figures, which of the following best represents, which of the following figures best represents the density of state, the density of the state, density of the density of the states, density of the states over range, over density of states over the range, over the range, over the range pi by 2a, k is between pi by 2a to pi by a. Okay, this is the question, and options are I'll make a figure. Okay, that graphs are given. Option A, is graph is like this. This is k axis. Okay, k versus this is density of state. Okay, DOS, density of state. Okay, I'm writing in short. Okay, so this value is pi by 2a, this value is pi by 2a, this value is pi by a. Okay, value of k, and this figure is like this. Okay, and option B is this is k, this is density of state, DOS. Okay, this range is pi by 2a, and this is like this. This is pi by a, pi by a. Okay, and this is going to be like this. This is this. Okay, next option is option C. Same thing. This is density of state, DOS. I'm writing in short. This is k. This is the range, that is pi by a, and this is the range pi by 2a. Right? And this is going to be like this. Okay, this one. And option D is again this is k, this is DOS, density of state. Okay, and this is the range, and this is pi by a, and this is pi by 2a, pi by 2a, and this is like this. Okay, so these are the graph. We need to select the correct graph, right? Okay, so question is, a tight binding model of electrons in one dimension, okay, has the dispersion relation. Okay, tight binding model of electrons in one dimension has a dispersion relation which is given epsilon k equal to 2t 1 minus cos k, right, where t is greater than 0, a is the lattice constant. Okay, and k is between minus pi by a to pi by a. which of the following figures best represents the density of state of the range this. Okay, so of this range, which of the following figure is the gives best representation of density of state in the range k is between pi by 2a to a. Okay, pi by a. Very good question, and I'm going to solve it. Okay. So, well, so here you need to understand. Okay, so we have been given that density or that E is given, which is function of K. Okay, is the energy E. Okay, and E. This is E type. Okay, this is E. E, which is function of K, that is dispersion relation is given. Okay, so that is minus 2t 1 minus cos K, 1 minus cos K. Right, this is given. 1 minus cos K. Right. So from here, this is going to be, so if we differentiate it, it is going to be dek, right? dek is going to be equal to, will differentiate with respect to k. Okay, so this is going to be 2t, and this is 0. Okay, minus plus 2t. Okay, minus plus 2t, and differentiation of cos is sine minus sine. Okay, so then this sine will 2t minus plus. Okay, then we'll differentiate cos k, so this is going to be 2ta sine minus sine, right? Minus sine k, 2ta minus sine k. Okay, now this is the and this is dk. Okay, this is dk. Okay, now we will find, that is, we know that gk value is, for 1D, gk value is L by pi dk. Okay, L by pi dk. So from so gk, so now what we are going to do, we are going to put the value of dk. Okay, so from here value of dk is going to be, implies value of dk is going to be de which is function of k, okay, upon minus 2ta sine k, right? So from here, now this is okay, this is what it is going to be, right? So now this is the one, right? This is the gk value, pi by this is, so gk value is going to be, this is gk dk value, right? gk dk value, gk dk value is this, L upon pi dk. Okay, gk dk value L upon pi dk, right? So from here this is the value of dk. We will put the value of dk here, right? So this is going to be, this value is going to be GED, because then it is going to be, right? GED is going to be GED is going to be L upon pi dE, which is function of k. Okay, d upon minus 2t a sine k. This is GED, right? Now we have to find density of a state. Very simple. So density of state, that is going to be, that is rho e. Rho e is going to be GED upon dE, right? So this value is this is GD, this value L upon pi, L upon minus 2 pi a t sine Ka dE into upon d, means upon d, right? Upon d, d will get cancelled. Okay, d will get cancelled, this one. So value of rho e, that is density of state, rho e is going to be this one, L upon minus 2 pi Ta minus 2 pi Ta minus 2 pi Ta into 1 upon sine K, 1 upon sine K, right? We can write like this, right? So this is the density of a state, guys. Very simple. We just need to know this Gk value, Gk dk. This value is L upon pi for 1 day, L upon pi dk. From here we'll find the value of dk, that is going to be GED. And density of state rho e is going to be GD upon d. This is the value. So this is the density of state. Now we have to find the correct graph, right? We have to select the correct graph. Okay, so now what we are going to do is, this is the density of state. Now at k equal to, at value k equal to, will find value k equal to pi by 2, because we have to find the best figure, right? That represents the best figure, that graph in the range this. So let the value of at k equal to pi by 2a, the range is given, right? This one. So at k equal to pi by 2a, the value of then the density of state is going to be, we'll put the value at, instead of k we'll put pi by 2a. So this is going to be L upon minus 2 pi. Okay, so minus 2 pi Ta minus 2 pi Ta into 1 upon sine k value, sine pi by 2a into a, right? A will get cancelled, and this is pi by 2, right? Sine pi by 2 value is 1. So okay, so we are not taking minus value. Okay, so this value is going to be L upon 2 pi Ta, 2 pi Ta. So this is a finite value, right? This is a finite value, right? Finite. Now we'll find at k equal to pi by a. At k equal to pi by a, the value is going to be L upon 2 pi Ta. Okay, 2 pi Ta into 1 upon sine. Instead of k, we'll write pi by a into a. A will get cancelled. Sine pi value is 0, guys. 0, 1 upon 0 means infinity. So this value is going to be infinity. Okay, right? This value is going to be infinity. We are just taking the value of density state. Okay, mod value of density state. We are not taking minus value. Okay, just mod we have taken. So at k equal to at k equal to pi by 2, the density of state is finite. Okay, at k equal to this, density of state is, you can see, infinite. Okay, so which graph is matching, you can check. So if you check this graph, okay, at pi equal to at k equal to pi by 2a, we can see it's a finite value, right? We just have taken mod value. So at this we can see finite value, right? And at k equal to pi by 2, we can see infinite value in the graph. This at k equal to pi by a, it is tending to infinite, right? Infinite value. So this is the correct answer, guys. Option B is the correct answer. Okay, okay, because at k equal to pi by a, it's a finite value. At k equal to pi by at k equal to pi by 2, it's a finite value, and at k equal to pi by a, this graph is tending to 0, that is infinite value, right? So this graph is the best representation. So we can say this one. This graph represents the density of a state. Okay, So this graph represents density of state over the range pi by a is between pi by a to pi by 2a to pi by a. I hope guys you have understood it. Well, so guys, I'm going to stop here. So okay, time is over. So remaining will do in next class. And also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, next class is going to happen for statistical mechanics and thermodynamics, and that is going to be lecture number 3 for thermodynamics and statistical mechanics. Okay, guys, thank you so much. Bye now.